Today we are going to see the testing of hypothesis with an example. Here, a coin was tossed 200 times and the head turned up 108 times. Test the hypothesis that the coin is unbiased at 5% level of significance. So, first let's assume that the coin is unbiased. Here, total number of observations, which is n, is equals to 200. Probability of success is 1 by 2, which is turning up head, which is 108 times, and probability of failure is the complement of probability of success. Now the expected number of success is equal to mu, which is equals to n into p. Here we will put the values in the formula. So we get mu is equals to 100. Now the observed success. Which is 108 times, which is also known as x. So here, first of all, we will calculate the standard deviation sigma with its formula under root npq. We'll put up the values in the formula. So we got the standard deviation is equals to 7.07. Now the standard error, which is also known as z. Its formula is x minus mu, which is nothing but the observed success minus expected number of successes, divided by standard deviation. So here we will put values in the formula. And get the answer 1.31 as standard error. So here we can conclude that therefore hypothesis is accepted. At 5% level of significance. And therefore the coin is unbiased. Because here the 5% level of significance value is 1.96, which is greater than 1.31, which is equals to z. Therefore the coin is unbiased and the hypothesis is accepted. Now let's get another example where a die was thrown 6,000 times and a throw of 5 or 6 was obtained 300 3240 times on the assumption of random throwing. Do the data indicate an unbiased die? Let's solve it. First, assume that the coin is unbiased. Now, here, total number of observations is 6000. Probability of success is probability of getting 6 and 5 out of the total faces is 6. So its probability of getting 5 is 1 by 6 plus, because here it's or, you will get plus, and probability of getting 6, which is total 2 by 6, which is nothing but 1 by 3. Probability of failure, which is equals to the complement of probability of success, which is 2 by 3. Now, the expected number of success, mu, is equals to n into p. This is 6000 into 1 by 3, which is equals to 2000. So here we got mu is equals to 2000. Now observed success. Which is equals to x, which is equals to 3240, which is given here in the question. Now the standard deviation sigma is equals to under root npq. So here I will put the values in the formula. And here we got the standard deviation sigma is equals to 36.51. Now the standard error z is equals to observed number of success minus expected number of success. It's nothing but x minus mu divided by standard deviation sigma. Here we will put values in the formula. And here we got standard error is equals to 33.96. So we can conclude that the hypothesis has to be rejected at 1% level of significance. Why? Because the standard error, which is equals to z, is greater than the 1% level of significance value, which is 2.58. Therefore, the die is biased.